This is Sung and I'm the Principal and Director of Sky Academy. In this particular episode, what we are looking at is a concept called the second derivative, which is a simple way of saying the derivative of the derivative. Okay, so the second derivative, and it's written like this, f double dash of x, is simply the derivative of the first derivative. Alright, and the first derivative being f dash of x for the function y equals to f of x. And the reason why we want to know the second derivative is that it measures concavity. And I'll go through what concavity is a little bit later in this episode, but just know for the time being that the first derivative measures the gradient function of a curve, the second derivative measures concavity. Okay, so let's familiarize ourselves with how to find the second derivative. So if in this particular example it says find f double dash of x, which is another way of writing the second derivative of f of x, and the f of x looks something like this. So we know from basic differentiation that when you're differentiating a polynomial, what you do for each term is multiply the coefficient by the power and take 1 off the power to get a new power. Okay, so let's do that for f dash of x. So f dash of x would be equal to 3 times 5, which is 15, x, 1 off the power, 3 becomes 2, plus 7 times 2, which is 14, take 1 off the power, and it just remains x. 9x just becomes 9, and the 5 disappears. Okay, so your first derivative of the function looks like that, 15x squared plus 14x plus 9. Your second derivative would simply be a matter of doing the same thing all over again for the first derivative. So multiply the coefficient, or the new coefficient, by the power. So 15 times 2 is 30. You put down the x, and the power of the x will be 1 less than the 2 that you've already got there, so it's 30x to the power of 1, which is just 30x by itself, plus 14x becomes 14, 9 disappears. So your second derivative of this polynomial, or of this function, is 30x plus 14. And we got that by differentiating once and then twice. Okay, so simply finding the second derivative is a matter of finding the derivative twice over, differentiating twice. Okay, what does it measure? It measures a concept known as concavity, and concavity can best be described in this way. See this smiley face here? Okay, this smiley face gives us if you remember from the last episode, it gives us a minimum at this point. But this whole section, this smiley section, is what we call concave up, right? And concave up usually results in us having a minimum, okay? And when a function is concave up and gives us a minimum, what we usually find is that f double dash of x, which is our second derivative, will be positive. So it will be greater than 0, and it will be greater than 0 all the way across all parts of this concave up curve. The f double dash, or the second derivative, will be positive all the way throughout. Does that make sense? This particular curve is not a smiley face anymore, it's a frowny face. It's become sad, okay? And this is what we call concave down, which makes sense because if this is concave up, this is the opposite, it'd be concave down. It's usually found because there is a maximum involved. Not always, but there usually is a maximum involved. Okay, so when there's a maximum involved, f double dash of x, so in other words the second derivative, in this case it was positive, in this case it would be negative. Does that make sense? Which means the second derivative, not the first derivative, but the second derivative will be negative all the way throughout the curve. It will even be negative at the stationary points, where the first derivative would be flat. Okay? Now, sometimes you have curves that are both a combination of concave up and concave down. Does this make sense? So in this particular, let's have a look at this particular curve, right? There is a bit around here that's concave up, and there's a bit around here that's concave down. Yes? So basically, the second derivative will go through a process of being negative, and so at some point it starts to be positive. Yep. And there's a point right in between the negative and the positive. Let's call this, let's say it's that point there, where the concavity changes. And at the point where the concavity changes, not only is f double dash equal to 0, which is what you would expect it to be, but the second derivative changes sign. Yep. The concavity changes, the second derivative changes sign. That point there is what we call a point of inflection. A point of inflection is basically where concavity changes. The horizontal point of inflection is where the gradient, the first derivative, is also equal to 0. In other words, it's a stationary point. But points of inflection don't have to be stationary points to be points of inflection. All that needs to occur is for the concavity to change. Okay? And this will come in very handy because it gives us another way of working out maximum and minimum, all right, or determining the nature of a stationary point by working out where the concavity is changing and where the concavity occurs, whether it's concave up or concave down. Okay, so hopefully that would have been a little bit helpful for you. In the next episode, we might do a worked example for you, and that will help you out a little bit more. Thank you very much for watching.
Hi, this is Sung again from Sky Academy, and I just want to thank you for watching this video. I hope you found it useful and at times entertaining. If you want to see more videos like this, you can either click here for this video or here for that video. And you can continue to get videos like this from us by subscribing to our channel, and you can do that by clicking above, or if you're watching on a mobile, please tap below to access our great content and resources. Thanks again for watching. This is Sung signing off. Bye.